Hey guys, today we're going to deal with some conservation momentum problems. First one, we're going to be stranded in a lake. So you're stuck in a boat in the middle of a lake. Luckily you brought your physics book. We're not going to use it as a paddle, but that might be a better idea. You decide to use it to propel yourself back to the shore, so you get mad at it and you throw it, your 1 kilogram book, overboard with a speed of 10 meters per second. So you throw it backwards, 10 meters per second, try to go propel yourself back towards the shore. Given your mass of you and the boat together is 100 kilograms, and it wants to know how long it's going to take you to get to the shore 60 meters away. So, and then we're going to ignore friction, obviously. So we're going to start by drawing a picture. Always the best thing to do. You're stuck in a lake. My picture is not going to be great. I have a little boat. This is me on a little boat. And I'm stuck here, and I want to get to the shore over here. This is my goal. So I'm going to throw my book that way. So I throw my little physics book. It's a 1 kilogram book at 10 meters per second. I know that my mass with me in the boat, I'll call it mass of big B, is 100 kilograms. So I want to know how long it's going to take me to get here. So first thing we got to figure out what we need. Well, we can use conservation momentum to figure out how fast my boat's going to start moving this way. And then we can use that and the distance we were given of 60 meters to figure out the time. Okay. So if we come back here, we're going to write down what we know. We know mass of the book is 1 kilogram. We know mass of me in the boat, which I'll call big B, is 100 kilograms. We know velocity of the boat, or the book, sorry, is 10 meters per second. And we need to know the velocity of us in the boat at the end. Okay? So if we set up conservation of momentum, we know that momentum initial has to equal momentum final. Well, our initial momentum is of us and the book together. So we take the mass of the boat and me plus the mass of the book times our initial velocity. And then that's going to equal the mass of the momentum at the end. So in the end we have two objects, mass of the book times the velocity of the book plus mass of you in the boat times the velocity of you in the boat. Well, at the very beginning, we're not moving, so we can say that all of this side right here goes to 0. So we're left with mass of the book times its velocity plus mass of you in the boat times its velocity, or your velocity, has to equal 0. So we're trying to solve for your velocity. So we're going to do a little bit of algebra. I would always try to do algebra first. Just that way, when you put numbers in, you don't have to move anything else around, don't have to worry about calculator issues. So first thing, get rid of this. We're going to subtract to the other side. So negative mass of the book times velocity of the book. In this case, the negative is just showing direction. So it really doesn't actually have a whole lot of effect other than the negative direction is going to be away from the shore and positive is going to be towards the shore. So times your mass of you in the boat times you guys' velocity. And then again, if I want to get rid of, just find the velocity, I divide both sides by the mass of you in the boat, and I end up with velocity of the boat equals the negative of mass of the book, velocity of the book multiplied, divided by the mass of you in the boat. Okay? So here we can just plug in some numbers. Mass of the book is 1 kilogram, velocity of the book is 10 meters per second, and divided by the mass of you in the boat of 100 kilograms. And that is going to give you a velocity of exactly 0.1 meters per second. So that gives you a velocity, but now we need to figure out a time that it takes for you to get there. Okay? So remember this velocity, 0.1 meters per second. So we're just going to come to the next page and write that up here. So your velocity of you in the boat is 0.1 meters per second towards the shore. Okay? Now we know that velocity equals displacement over time. So if we wanted to figure out the time, we do a little bit of algebra, solve for change in time. Change in time equals change in position over velocity. Okay? And we plug that in. Well, change position is 60 meters over our velocity of 0.1 meters per second. So that's going to give us 60 divided by 0.1 which should be 600. Meters divided by meters cancels out. Your second flips to the clock, 600 seconds. So 600 seconds is how long it takes you, and converting that into minutes, that's about 10 minutes. So it might take you a while, but you will get there.